this video, I want to explain moment of inertia of ring, moment of inertia of a ring. So full derivation I am going to give. See, this is a ring. This is the axis passing through center. This is the radius of the ring, that is R. So we take an elemental part of the ring, that is dx. So the dx is making angle at the center of the ring, that is d theta. This is R. So from arc we can this is a relation between dx and r d theta. Dx equal to r into d theta. The mass of the ring is capital R, capital M. So radius of the ring is capital R. So for this derivation we have to follow three steps. First is lambda. First is lambda. So for lambda, lambda is nothing but linear density, that is total mass of the ring by total total perimeter. So that is equal to m by 2 pi r. So this is the linear density of the ring. So take elemental mass, that is dm equal to m by 2 pi r into dx. So that is equal to lambda into dx. That means this is a linear density, this is the dx. So each part it is having linear density. How much dense the length is the dx? So lambda into dx, that is lambda dx, elemental mass. Here we are moving to third step, that is equal to moment of inertia of ring, that is equal to dm into r square. Dm into r square. The elemental mass is from the axis, distance is r. So general moment of inertia formula m into r square. Here we take an elemental mass dm. The dm mass is distance from the axis is r square. So m r square dm r square. Just substitute what is dm equal to m by 2 pi r. Then m by 2 pi r into dx into r square. So m by 2 pi r square dx. So just to calculate m r by 2 pi dx equal to r into d theta. R into d theta. Here we have that one. Then m r square by 2 pi whole d theta will be there. So integrate theta from 0 to 2 pi. Then m r square by 2 pi minus 0. If we integrate, so finally that will be here lies. So this is equal to m r square. Equal to m r square. The moment of inertia of ring about central axis, that is equal to m r square. So this is a simple derivation for moment of inertia of ring.